All right, so we're just going to continue our lecture from last Thursday. So we're still doing series, in this case, power series. Um, I just want to do a few more examples of last time's what we were using, but the idea is we were trying to find the power series representation for f of x. Right? In this case, we were using sort of the rational function um, to determine sort of its power series representation. In that case, we were using essentially the geometric series, right? So where a over 1 minus r is equal to the sum from n equals 0 to infinity of a r to the n power, right? So we were using that. And sort of just a quick review, right? So example. So number 1. And so if your f of x is equal to a 1 over 1 plus x squared, the idea is to find or to match this with this expression, which is the sum of your geometric series, and try to figure out what a and r actually is on the problem. And so obviously here it has to be 1 first, right? So that has to match. And then from there, a is what? So a is 1, right? And then r is what? Negative x squared, right? And so now with that, okay, using this, it's just plugging things in. And so our power series for our f of x is n equals 0 to infinity. Okay, and then a is 1, so this is going to be 1 times negative x squared to the n power. And then just write it out nicely in terms of what we want as a power series, which is basically you have your coefficient and then you have your x sort of the expression. And so in this case, it's from n equals 0 to infinity. So the negative 1 to the n, right? Because it's negative, right? And then you have the x squared to the n power, which is x to the 2n power. Any questions on that? Any questions on it? Okay. All right. So far everything that we did, the center was at 0. Okay, and so I wanted to do one today where the center is not 0. Now remember, center, at least our book's notation was using a. So remember that a is different from this one, right? So don't confuse the two. So for now, I am gonna write the word center, just to tell you that you have a different a than this one, right? So um, number 2. Okay, so let's do f of x. Okay, is equal to a 3 over a 4 um, minus 2x. And then let's say the center is, I want it to be 1. Okay, so if the center is 1, then that means I need my r to be x minus 1, or at least have an x minus 1 in it. I shouldn't say r. Okay, I shouldn't say r. Let me erase that. But basically, I want my power series, this one, to be x minus 1. And so I need that over there. So I need that to be x minus 1. And so we're going to algebraically try to put x minus 1 there. Okay, so now let's go ahead and do that, right? So this, right, is going to become 3 over 4 minus 2. So this x, I want that to be x minus 1. Now, I can't just do that, right? I can't just put x minus 1 because that's what I want. So I have to algebraically get there. So you have to sort of balance what you just did. And so here I put minus 1. And so in reality, that minus 1 is multiplied by negative 2. So negative 2 times negative 1. So by putting that negative 1 there, I'm actually adding 2. Okay. And so that means if I'm adding 2, then that means I'm going to have to subtract 2. Right? And so now just looking at it on the side, right? So if I look at this on the side and then just simply distribute, so that would be 4 minus 2x plus 2 minus 2. And notice you get 4 minus 2x as a result. And so this is equivalent to that one. So they're the same as what you had before. And then now just sort of simplifying things out. So you get 3 over. So this 4 and negative 2 would give me 2. Okay. And then you have a minus 2 x minus 1. And then now try to match this to that one. And so first thing is to get the 1. So this 2 has to be 1. So you do that by dividing. So by dividing everything by 2, okay, we now have 3 halves. So we now have 3 halves over a 1 minus, and this 2 would cancel, and you're left just simply with x minus 1. So now with that, what is a? 3 halves. And what is r? X minus 1. And then now that's what you want, right? So you want that x minus 1 to have the n power. And so now writing that out as a power series. So it will be n equals 0 to infinity. It's 3 halves. And then x minus 1 to the n power. And there is your answer. Any questions on it? All right, so if there are no more questions, okay, you can actually do some more functions, again, sort of using this, but doing some calculus on it. Okay, so for example, okay, suppose I want to find number 3. F of x equals ln of 1 plus x. So looking at that, right, it doesn't look like a rational function, right? So that is not a rational function. Okay. However, the derivative of f, so meaning f prime of x, okay, what's the derivative of ln of 1 plus 1, or sorry, ln of 1 plus x? So what's the derivative of f of x? Anyone? It's your natural log, so it's 1 over, and then derivative of 1 plus x is 1, so the chain rule doesn't really give you anything but 1. And so the derivative is this. And this we know how to do, right? So this one we know the power series for, right? So this one, the a is 1, the r is negative x, so the power series for the derivative is basically -1 to the n, x to the n power, right? So the negative because there's a negative x on there. But this is our power series for this one. Okay. Well, how do we get this then? Well, we have to go backwards, right? So since this is the derivative, I have to go back to this. So what calculus operation do I need to go from here to f of x? So what operation do we do? Because there's only two calculus operations, right? Derivatives or integration. So how do I go from here back to the original? Integrate. Good job. So you integrate. Now, how do you integrate a power series? Well, remember, power series is a polynomial. So you're taking the integral of a polynomial, and well, a polynomial is just a power rule. So then now apply the power rule on the polynomial, and so your power series then, remember, x is the variable, so this would be -1 to the n, and you get x to the n plus 1 power, right? So you add 1 to the power, divided by n plus 1, and then remember, it's a indefinite integral, so there's always a plus c. Any questions on that? Any questions on it? All right, now you can't leave it like that though, right? So you can't leave the plus c in there. You're gonna have to find the value of c. Now, how do you do that? Now, the way you find c is you need to know something about your function. Oh, good question. So why aren't you adding a -1 or a plus 1 right here? Because -1 is a constant. So this is considered a constant. So the variable is x, so your focus is on the x part. So it's kind of like having a 2 there. So that 2 just carries over because it's not a variable, so it's a constant. So you don't really touch that power. So this is why you have to remember what your variable is and what you're doing, right? So when we were taking limits before for your power series, the limit had n as its variable, so you had to keep the n on there. But here we're integrating. So remember, x now is our variable, and so when we're integrating, we're only focusing on that, right? So this is considered a constant as well as n. N is considered a constant, okay? So n is actually just a number from 0 to infinity. And so hence, you're not integrating the -1 to the n, you're only integrating the x. Anything else? Okay. All right, so back to C, right? So we need to find the value of C. So to do that, you need to know something about your function. Well, we actually know the function. The function is this. So one way to get this is to just plug in a value for x. So suppose if x is 0, so if I plug in 0 for x right here, okay, then we get natural log of 1. Well, natural log of 1 is 0, so that means f of x is 0. So if f of x is 0, that means if I plug in 0 to my power series, the answer should be 0. Well, since all my power series has an x, right? So it's basically x to a power. That means it's just going to give me 0 if I plug in 0 if c happens to be 0. So which means this c is actually 0 as well, which means our power series really is just n equals 0 to infinity, -1 to the n, x to the n plus 1 over n plus 1. And that is our power series representation. Questions on it? By the way, the center here is 0, right? So unless it's not clear, the center is 0, right? So we're going back to the 0 center. Questions?